Good day, students. Today we're going to look at a solution to number 6 on page 99, your Math 1026, booklet number 2. This is chapter 4 that deals with quadratics. So we're asked, again, this is one of our examples of max-min problems, but we're asked here to find the largest possible dimensions. So we're looking for the word max or min, and that might not appear, but largest or smallest would do as well. And in this case, we are asked that, aren't we? See that word there? Largest possible, okay, largest possible lot. So this is an example of a max-min problem. Okay? Now, in the instruction that you don't see it there now, but it's said at the top of the page, to set up a quadratic equation and solve the following problems. So we want to set up a quadratic equation, right? So the first thing we're going to do to set up that quadratic, and then we'll look at the quadratic to answer our question. But you have to set up that quadratic equation first. Now, very similar to the last video when we were talking about numbers that differed and minimum product. Now we're asked to find the dimensions. Now dimensions of a rectangle, of course, are length and width, right? The dimensions here are length of a rectangle and the width. Now, so that's what we're looking for, the length and width of a rectangle. Now you can use X and Y, L and W. Where it's a rectangle, I think I'll use L and W. Now notice it's only a three-sided rectangle. I know that sounds funny to say it, three-sided rectangle, but the river is acting as the fourth side. So we don't have a length over here, because we're not going to put any fencing along that side. So the river acts as the fourth side, if you would, right? So we're only dealing with one length and two widths. Now, to set up that quadratic equation, what do we do? Very similar to what we did the last time. We're going to take the information, okay, and set up two equations, a linear function, a linear equation, and a quadratic equation. And we'll use the linear to help us set up the quadratic. Now the linear equation here is the amount of fencing we have. We have 800 meters to go, some here on this width, some on this length, some over here. So we're going to put 800 meters along that. Now what is that called when you, okay, so we're basically going to do this now. We're going to take 800 meters of fencing, and we're going to put so many meters here, then so many meters along here, right? So we're going to put so many along here this way. Oops, let me just get my, right? And we're going to put so many along here, and we're going to put so many along here. But we only have 800 meters of that. So that has to add up to 800. Now what's that called? Right? Yeah, exactly. That's the perimeter, right? That's the perimeter. So the perimeter equation is the equation, or our linear part, right? Our linear function. So the perimeter here is what? We only have two lengths, one length, sorry, and two widths. And that must add up to 800 meters of fencing. See how I got that? So L plus 2W is 800. But now, we're not asked to find the largest perimeter or maximum perimeter. We're asked to find the largest or maximum area. So this is the equation we have to work with. So we use the perimeter and substitute it into the area, just like we used in the last video, the difference, and substitute it into the product. Same idea, same concept. Now what do we call area? Well, let's use capital A for area, because we don't have a value. We're going to use a variable to represent that. And the area of a rectangle, you know by formula, is length times width, L times W. Okay, so there's your two equations. Now it doesn't look like a quadratic yet, the area equation, does it? But however, we're going to use our helper over here. This is our helper. We're going to use this one to help us make area a quadratic. Now how do we do that? Well, we want to substitute in for W or for L so we can write the equation in one variable. Alright, so that's what we want to do. Now, so we're going to solve for either this L or this W. And it's your choice, really. However, I think there is a simpler choice of the two. And that's right, we're going to solve this one for L. So if we solve this one for L, oops, let me take that away. Go back to my pencil. We're going to subtract 2W from both sides, so we get L equals 800 subtract 2W. Now, take that amount and substitute it into the other equation. So take this and put it in the other equation for L. Let's see what we get. So A equals L, which is 800 minus 2W, times the W that's already there. So there's our equation. No, still doesn't look like a quadratic. No squared term there yet. But watch, when we do the distributive property, we get 800W minus 2W squared. Now there's our squared term. Now again, just force of habit, and a lot of people like to do this, they will change it around slightly by moving the squared term in front. Negative 2W plus 800W. And notice there's no C value. I mean, you can write it in if you want, plus 0, but there's no need. So there's our quadratic right there. So now we have our quadratic. Now once you have your quadratic equation, what do you do then? Now you know it's a max. You can tell it's a maximum, can't you? Because of this A value. Look at A. A is negative 2. Right? That means we know it opens down, don't we? As a parabola, it would open down. Therefore, the vertex would have to be a max. See? So we know that once we find a vertex here, we're going to get a maximum point. Now, how do we find the vertex? And anytime you see largest or smallest or maximum or minimum with quadratic equations, you know you have to find a vertex. So how do we find a vertex? Or how do we find those values? Because the vertex is what tells us it's a maximum in this case, or it is a maximum point. Now we know x equals minus b over 2a is the x value of the vertex. Now x in this case, of course, is w, isn't it? W is x, right? So what we have here is w equals minus b over 2a. Right? Now, we don't need to find the whole vertex. The x-coordinate of the vertex will do in this case. So minus b over 2a. Let's put in minus b. Where's b? B is 800. See how we got b? Right? You should be able to see that b is 800 right there. Over 2 times negative 2. Now, how did I get a for negative 2? That's right, right there. A is negative 2. We've already looked at that. So I got negative 800 divided by negative 4. And of course that is 200, isn't it? So it looks like the width is 200, and in this case meters. 200 meters. Now how do we find the length? Well, look, we know what the length, we already solved for L. So put it back here for W. See where I'm putting it back? Right there. So L is 800 minus 2W. So that's 800 minus 2 times 200. So that's 800 minus 400, which of course is 400. Now, so it looks like the width is 200 and the length is 400. Now they should add up to what? What should that add up to? 800. Let's do a little check there. Let's do a little mental check there just to see. 200 plus 200 is 400. 400 plus 400. Yes, indeed it is 800. So there's your answer. Now how do you write your final answer? Write something in words. Like over here I'm writing the length is 400 meters. The width is 200 meters. Therefore the maximum or largest area is 400 times 200, which is 80,000 meters, square meters. I just multiplied 400 times 200. Now it didn't ask us for that, but you can give that value anytime as well. So there's your final answer right here. 400 by 200 meters.